There's actually really
yeah, I'm taking in the evening. If I did in the morning, I wouldn't be able to work at all during the evening. Steps can happen. And then the well, we don't trust you. I'm gonna have to say is what the TLC Thursday. Yeah. So analysis and design. That's I got you. That's what I'm doing this semester, but take analysis and design. Oh yeah, and I'm trying to schedule it to where you're all. Yes, it's like I go to all the Walmart areas where it's not riveting. It's big bill.
agencies, if not during
I'm sure.
Oh, wait, no.
The zoning has approved now. So it was gross, so we went to Walmart.
A lot of our writing.
Yeah, and we, I mean, it's gross. Well, we use the awful interest. But it hurts. You got your eyes. But it was interesting. I can't say that I can never expect to get it. But I don't think it's confusing because they want you to take this class, but they also don't want you to schedule it.
Yeah.
Like, I don't want to go to work, go to school, go to work, from school, all the day.
Yeah, like the back and forth is all.
I only work 4 days out of the week.
Yeah.
But it does have to, the bill says they want to do it's class or that to you.
It's just like our.
Yeah, okay.
Funny.
152 kids from 130. Can you see it? Like, can you see it? Like, can you put it in the register? But not register? I would have not been doing it on that. Because you can look at it.
Okay, I'll send the picture of the check later.
Okay, can you send it to us? We want the check picture. Mute yourself. Mute yourself.
And if you don't mind, if you could give us that information on the program back here. Social security number would be nice too.
I don't see it. Right now, I haven't found that. Yeah, I had some guest speakers in the C#2 class a few weeks ago, and I wanted to do a thank you card, and a bunch of people are working remote, and I thought, well, I'll just ask them to send their signatures. Maybe I won't. I thought, you guys can just send me an image. Okay, well, maybe I don't need to collect all of those, but it would be kind of fun. Sometimes you don't think of stuff. Well, speaking of that, last time I told you guys that we would spend all day today as a lab day, and I've reevaluated, and I think that we should look at our chapter 9 material on subprograms before we break into lab, because when you guys are doing your quest, It would be a lot easier for you to divide up the work if we were writing subprograms or functions, right? And then you could say, this person is going to write this function, and this person is going to write this function, and this person is going to write this function, and we're going to put them all together. So I kind of have re-evaluated. I try to not do that very often, but I think it's important in this case. So I apologize, but let's take a look at our modules, and we'll make it somewhat quick, and then we'll get to our lab time. So we're in week 11, and in week 11, we're going to talk about modular programming, or our functions. So that is actually chapter 9. We're skipping a couple of chapters, chapter 7 and 8 in our Prelude to Programming book. So if it feels like you're moving too far ahead in that book, you're right, you're skipping a couple. We're going to go back to them. But that means there is an example or two in chapter 9 that refer to code from chapter 8. So we're going to ignore that when we talk about it, and you'll need to do that same thing if you're reading the textbook, looking through it. Just one example that's kind of dependent on that stuff that we've skipped a little bit. So let's see here what we've got with our chapter 9. I'm going to start with the textbook PowerPoint. And the extra PowerPoint that's out there is one that you could look at on your own. It shows a lot of sample code, and it actually shows changing a program from being straight through or sequentially executed, like what we've been doing here lately, to being a modularized program. So if you'll remember, when we started out, our very first couple of chapters, they told you guys about splitting up into subprograms, about creating modules. And they said, this is the way to develop software modular programming. We want each piece to be independent and kind of stand on its own. And then we sort of veered away from that a little bit. They're like, oh wait, you guys are brand new programmers. Let's just look at some sequential top-down code that runs from the beginning to the end. So that's what we've been working on. And it's kind of confusing, I know, that we go back and forth between the two. So today we're going to look back at creating subprograms or modular code so that we can really, really separate things out into their functions. So whenever we were looking at our subprograms, what we've done with functions so far, and back up this train just a little bit, anytime we have a subprogram, we're talking about a piece of code that we have decided performs some sort of reusable activity. So we're going to identify that chunk of code as a subprogram. Depending on the programming language that we're using, we could call that subprogram a module, a subroutine, a function. In C# and Java, we call it a method. So a lot of different names for those subprograms, but they're all the same thing. Just a chunk of code that we've decided we can reuse or performs a logical function. So we're going to make it into a subprogram. So when we've done that so far, if our subprogram needed data, we just made that data variable global, right? So our global variables are variables that are considered global in scope. And the scope means no matter what part of my program I'm in, I can still see that module or that variable, and I can still see the contents of that variable. That's a global variable. We put them up at the top of our code, and we specified that they're global, and then we saw we had to do extra things with them when we were going to update them within our Python functions. Well, using those global variables is fine for beginning programmers. It makes things nice and simple. We can update a variable in our input subprogram and then read it in our processing subprogram, and everything's all fine and good. But that means that those two subprograms are dependent on each other, right? Because they're using the same variable. They're using that same global variable. So now I can't say Joe's going to write the input function and Anna's going to write the calculate function, because they're going to have to talk to each other. What did you want to name that variable? Oh, well, I wanted to name it such and such. Okay, well, I'll go ahead and say that I'm going to update it in my module, in my function, and then in your function, all this back and forth, right? Because we're sharing these global variables. So we don't want to do that. So true modular programming involves each subprogram being independent of any other subprogram within that application. So that means we have to get data back and forth between these subprograms. How do we do that? How do we get data from one subprogram to another? Well, we've actually been putting code in to make that happen a little bit. Our parentheses, our open and close parentheses that we've put at the end of a function name in Python, we would use those parentheses to specify variable names of data that we need to use in that subprogram. So we can keep track of that, what data needs to be passed between one subprogram to another in a data flow diagram. And we'll look at one here in a second. So if I have some data that I have available to me in my main function, and I need that data in a subprogram, a submodule, I can pass that data to that subprogram. When I do that, we say that that subprogram imports that data. Now, on the other hand, if an item processed by a subprogram is needed in the main, like we calculated some amount that we need to get back to our main module, it has to be returned to or exported to that module. So we say that we pass a value to a subprogram, and the subprogram may or may not return a value to the calling program. So I'm going to think about it like I'm a piece of paper here, and I've got this need to know something. And what I'm going to do is I've got my variable here. I could pass this to the subprogram, let the subprogram do some calculation, and then it would return that data back to me. So let's see how we would do that in a data flow diagram. A data flow diagram is just a hierarchy chart, and a hierarchy chart is simply rectangles. Each rectangle names a subprogram that's in our overall program. And all this hierarchy chart shows is which module calls the other module. So in this example, our main module calls the welcome message, the input data, the compute results, and the output results module. Now they happen to be in order here, right? The order that we would call them, but they don't have to be. We could have this just completely mangled and messed up. All we need to know is that the main calls the welcome. Where is the welcome called? Oh, only by the main. So think about it, we can actually see that reverse information there too. I can tell, is my welcome module used in a lot of places? Oh no, it's only referred to in our main module. Now what makes this a data flow diagram is it's showing the movement of our variables in our data. So if our main module calls the welcome message, our welcome message doesn't need any data. It just displays this nice message out on the screen. Welcome to our program, and it's done. But now, if we call our input data module, the input data module is asking our user for the original price and the discount rate. So when it gets those pieces of data, it needs to return them back to the main. If it's going to stand alone, and in its main are going to be completely separate from each other. They don't do any sort of, oh, here's a global variable. Oh, here I updated that global variable for you. Instead, they say, we're completely separate. My main says, I need some data. I'm going to call my input data module. My input data module asks for that data and returns it back. So now the main is going to have access to the original price and the discount rate. Now the next thing the main is going to do is decide to call a calculation. to use those numbers to figure out the sale price. So in this example, the calculation module is called compute results. Before it can do any computing, it needs to know what the original price and the discount rate are. So those two data variables have to be passed to this compute results module. If it's going to stand alone, it's going to be a cash register over here saying, I can give you the sale price. I'll give you the sale price all day, but you got to give me what the original price was and what the discount percent is. Then I can calculate it and give it back to you. So these two variables are going to be imported by this module. The sale price is going to be exported or returned by this module. Finally, when we call our output results, it can't output anything if it doesn't know what the value of those variables are. Again, they're not global. It can't see them if they're not global. So we have to pass all three of those data items into our output results module for it to do its job. So it's just like the very first time we talked about pseudocode, and we said we have an input and a process and an output. We kind of always do, right? Have you noticed? Now, when we're looking at a specific subprogram, same thing. Each individual subprogram can have input, do some processing, and output. They don't have to, right? This one doesn't have any input, and it doesn't return anything. All it does is some processing, printing some things out to the screen. This one, it doesn't return any values, but it does have input, right? This one has input, processing, and output. So our subprograms are basically that, little pieces of programs that can do the same type thing as we would see in a large program. Okay, so whenever we call a subprogram, we're going to use some special syntax to say we're going to pass these variables. Let's go look at our Colab module for this week instead of looking at that PowerPoint so that we can do some code and see how it works. So in week 11, the Colab notebook that you want is this chapter 9 one. Let's open it. Oops, it let me open it, but I'm not on the right Google account. Hang on, let me fix that. I'll be in trouble. That's why it takes me so long to get videos loaded and stuff. I have like 12 Google accounts. I have to use the right one or I'll never find anything. Okay, so on our Colab notebook, first thing we want to do is save it. So I'm going to save my copy and then take a quick look at it. So for this week, it is a shorter one. Let me zoom in a little bit. So we start out our first section, 9.1, has data flow diagrams, arguments, and parameters. And it starts out with that same sale price program. Then we have a couple of other sections, but it's actually much, much smaller than the one we did the other day. So let's start out with the sale price program pseudocode. We were just looking at that data flow diagram, so it should look really similar to this pseudocode. Our pseudocode, if you notice, we have the same subprograms, right? Here's our welcome message. All it says is display a brief description of the program. It doesn't even have pseudocode. We'll put some stuff in there. We have our main module that calls all of our different subprograms. Here's our input data module and our compute results and our output results module. So notice how splitting these into separate subprograms has made each of the subprograms really, really small, really, really manageable. So now we have a lot of different pieces that have to fit together, but each of our pieces are really small, really easy to fix, really easy to update. So if I have some sort of problem, like my company comes and says, we have a problem with this formula, we need to change it, I could just go find that formula in my compute results module, make that change really easily, retest everything, and I'm back in business. It's not all buried in this top-down code that just kind of goes on and on forever. If you notice, it actually does make things easier to maintain. Plus then, I can say, Joe is going to write the input data module, Sarah is going to write the compute results module, and they don't really have to visit with each other, right? I can say, this is your requirements, this is what you need to come up with for your module. So modular programming makes more maintainable code that's easier to assign responsibility for. So let's look at that data flow diagram again. In this version of it, that's a little marked up, notice all of the things that are flowing to subprograms that are going to be imported into are highlighted in yellow. The things that are the data items that are returned by or output by subprograms are circled in red. And each of our rectangles is documenting a specific subprogram. So we can kind of see our important things there. So let's look at this example before we get into that big sale price program. This is the example that we were just about getting to in that PowerPoint. So we have 3 data items, the old price, the rate, and the new price. Just like our sale price calculation, right? The original price of the item, the discount percent, and then the new price. So we could say, I love this pictorially, see this picture? It's not really very picture-y, is it? It's these arrows, see how graphic that is. So say, I want to call my output results function. We know from our earlier experience that in pseudocode, we put the word call and then our module name. Now we also, if we remember, I remember, in Python, we don't have that word call. We just say our module name, and that does the call. But now, instead of having these empty open and closing parentheses like we've always had before, now we have stuff inside of our parameters. And those are all the variables that we want to pass to that subprogram. So our output results module needs to know the original price, the discount rate, and the sale price to output all that stuff. So in order to make that happen, we would list those variables in between the parentheses, and they become arguments. They are now arguments that are going to be passed to the output results function or subprogram. Now, my output results subprogram, again, when we defed these things, we said def output results, open and close parentheses, colon, if you remember in Python. Well, we're going to do that same thing, but now again in our parentheses, we're going to list all of the data elements our subprogram needs as input. They're going to be separated by commas. And when we call a subprogram, we need to have the same number of arguments as we have parameters in our subprogram definition. They need to be in the same order. So they don't have to have the same name, but they have to be the same number of them and in the same order. So if I switch these around, it wouldn't work right. Let's try it. Let's write some code here. Oh, it's already written for you. Because this is our first time we've actually used Python code that has variables. So what your assignment is for this code, since you didn't have to write it, is you need to comment each line of code to say what it does. Now you could put a comment before the line of code, Or you could tab over to the side and put the #, the hashtag, and then put your comment after that. But I'm going to leave that for you for later. For right now, let's talk through it and let's see what's going on. First of all, whenever we write subprograms in Python, if you remember, the subprogram has to be defined before we can call it. So that makes it where we sort of do start at the end of all of our subprograms, and at the very end of our Python program, we finally have our main module. It's a little backwards from what we think, but that Python interpreter has to see this output results module before it'll let us call it. So a little bit backwards. So the first thing that's in this program after the comments is the def statement to create a function named output results. Let's put that comment in. I'll help you a little bit. Create a function named output results. This function requires 3 parameters. And we can see those right there. We have our original price, our discount rate, and our sale price. And it outputs the data. Now, in the print statements themselves, there's some special formatting. We've kind of skipped around talking about formatting our Python output because we've been more worried about our actual code. But these give you some examples of how to format numbers with 2 decimal places. So this says, print out this message. The original price is, and then these curly braces say, I am a replacement parameter. The replacement parameter says, I'm going to print a floating point number with 2 decimal places. Then we close our double quotes, and then we have this special keyword format, and within the parentheses for the format function, we specify the variable to use in that parameter replacement. So I'm throwing a little bit extra stuff here at you. Besides just defining our own functions, we're going to use a new output formatting function from Python that we hadn't used before. So I've got my def module or def statement all set to declare my function. Right down here on line 19 is where we call that function. So call the output results function. And we're going to say that we are supplying arguments. So each of these arguments then are going to be used to replace the parameter. Argument to parameter. Now let's run it. In this program, I set up the old price rate and new price variables with values here. And then we call our function just to output them. So let's run it. So there we see that our price has been used as original price in our output results function. Our rate has been used as our discount rate in our output results function. And new price has been used as sale price. So notice how those variable names can be different. That data is getting passed to our function, and then our function is using it. Let's change our old price to 300 and run it, and we should be able to see the impact on all of our data items. Awesome. So let's copy this code and let's run it on that Python tutor website where it visualizes our code for us. I'm going to paste that in there. This is a nice little one. Shows up on the screen. So I'm going to click Visualize Execution. And right now, execution is halted at the end of my comments, waiting for me to click Next. When I click Next, we're going to see that red arrow move all the way down as the interpreter is reading our output results function. It's not going to do anything with it yet. It's just, oh, I've got to figure out what this thing is. So there, it's going to take a look at it, and it created it for us. It said, oh, I have this user-defined function called output results, and it wants those three things. Now it's sitting at our main, ready to start executing our main. Let's click Next. Same thing. It created our main function. So it knows those things are out there in memory. Now we're finally going to run our main. So when I click Next, we should see our main start executing. First, we're going to allocate our old price variable as a float with a value of 300. Then we're going to allocate our rate variable with a float as a float with a value of 20. And finally, our new price variable. So now all of our variables are sitting here in memory, but they're local. Only our main function knows about these variables. See how they have that word main up here? They're not global. They're only known about in our main. Now I'm going to click Next again, and it's ready to run our output results function finally. So here it goes. Now it started out saying, oh, output results needs all of these values passed to it. So see how we have a whole new set of variables. So our local variables in our main were named old price, rate, and new price. Our local variables in our output results module are named original price, discount rate, and sale price. They could be named the same thing if we wanted them to, but they don't have to. But see how now, instead of having one set of those variables that's global, I now have two sets. It seems kind of like wasteful of memory, doesn't it? But it makes them be independent of each other. They're not dependent on each other anymore. Now let's click Next. And we should see our output results function run. It's going to take those data variables and output them with the print statements. And then when we next, we should be all done. And we're completed. Questions about that? Now, looking at your Python tutor website, what would happen if we changed things around? Let's say we had things in the wrong order when we called our output results. I'm going to edit this code, and I'm going to change it so that my rate is first instead of my old price. Just made a mistake. Just wasn't paying attention when I did it, and I got them out of order. So let's see if that has an impact on our output. If we visualize execution and we run it, our variables are getting set to the same values. And when we call our output results, again, see, now our old price got passed in as the discount rate. And our original price instead ended up as the rate. So we have to have our parameters and our arguments in the same order. That makes sense? If they're not in the same order, they won't be the right data. Okay? So for this example, 9.1, you're going to come back and you're going to comment each line of code here so that you're clear on what's going on with it. And again, if you have to, you'll go back to that Python tutor site and execute it, see what's going on, call me, say, what are you talking about? Okay, example 9.2, a little bit more about passing data. This is in that PowerPoint, but we're just going to look at it in our CoLab document. Let me make sure I'm not leaving anything out. I think we're covering all of our stuff here. Okay, we're in pretty good shape. All right, so example 9.2. Here we're continuing to refer to our sale price, and here's our pseudocode for our output results. And they want to show you that this other pseudocode would work just as well. Can you tell the difference? There's not much difference, is there? What they did is, in this example, they used variable names that are different than what our default variable names are. And in this one, they use the same variable names as the variable names in the main. Works the same. Again, when we call a subprogram, the system that's doing that connection, that's passing that control off to that subprogram, is never going to look at those variable names. It's only going to look at, let's see, this is that memory location Fox 9. This is that memory location, you know, Box 57. I've got to move this to here, move this to here. So we're only talking about where things are in memory. So variable names are only meaningful to us. So it doesn't matter how we change them. Now, in this activity, student activity 2, again, this is going to be one that's for you. And in this one, I want you to try to explain how arguments and parameters are passed. It's not going to be a short thing, is it? You can see I've stammered around up here for 20 minutes or so trying to explain it to you. So it might take a little bit more than a sentence or so, but I want you to think of what is a meaningful explanation to you. I'll let you do that on your own. And we're going to continue on with example 9.3. Here we have a horse of a different color. We have a pet store owner. Her name just happens to be Katrina Katz. That's cute, isn't it? She wants a subprogram, a function, that will display the type and color of a pet ordered by a customer. So the program statement that they've given us has a call statement that sends 2 arguments to the subprogram. The arguments are the color and the type of the pet. In this call statement, the arguments passed to the subprogram are actual values. They are not variables. However, the parameters in the subprogram header must be variables. In this example, they take on the values of yellow and duck. The subprogram simply displays the information sent in. So let's see if we can create these pieces. First of all, I want to create a Python script that does this sort of thing. So I want a function named animal. Let's start on that. I'm going to say this script is our animal script. You will be the developer. Pass arguments. Because this time, we want to see how we can use literal values or variables. So first, I'm going to def my animal function. And my animal function is supposed to accept 2 variables, the color and the beast type of animal. And then our animal function is just going to print it out. Print the pet you are buying is a color and a space, and then the type of animal. So a really, really short function. And as a beginning programmer, it's really normal to say, why do I need a function here? It's just that one line of code. It's more trouble for me to create the function and call it than it would be to just put that one line of code in my main module. That's true. You're absolutely right. And it stays that way throughout the real world too. But the thing we can't know is, what about if they come back in a month and say, you know that function, that animal function, where we just print out the type of animal it is? Well, I want to add a whole bunch of logic to that and say, if it's a cat, I want to do some analysis on the color and determine if it's a calico cat or if it's a Siamese cat. And so now my animal function that just printed out this one line of code becomes a really involved logical function that determines the type of animal and prints it out. Or maybe I have another function that does that. But every time we take something and logically separate it, we are doing the right thing with our code, because there will probably be something come along that's going to make us increase the amount of code in that function, pretty much 9 times out of 10. All right, so how do we call it? Well, we can just call it by saying its name, animal, and then we don't have to have variables, is what they're saying. We can call this thing passing in a duck that is yellow. And now I'm going to add a line of code to run my main, and I should be able to try this. So I should get the pet you are buying is a, oh, I want yellow duck. Is that what I'm going to get? Instead, I'm like Mandalorian speak, aren't I? So I got to fix that. It's not exactly right. Now, which one is wrong? Well, that just depends, doesn't it? If I already have 15 calls to this animal function in other parts of my program, then I'm sure not going to change it. But if it's like this, where this is the first time I've called it, well, I can decide which order is more logical and go with whichever one I prefer. We already have it as color and beast, so I'll get rid of that duck and put it after our color. And now I should see that I have a yellow duck instead of a duck yellow. So our order matters. Now I could call that thing some more. Animal brown bear. Run it. Great. So now I want you, I'm going to ask you then, I'm going to give you a couple minutes. I would like you to call this again using variables. So I'm going to say my color and my beast equals X. So now put a call in there for me to call our animal again, our animal function, so that it prints that out properly. Get it? So we want to call our animal function, and this time we would use our variables, COL in BEAS. And then we should see some information about our purple ox. Let's try it. Okay, so we got it. So we can have, for our argument, we can have variables to pass data, or we can have an actual literal value that's within the double quote. We could have the number 5 if we were passing in a number. So we can call our functions either way. Does that make sense? Seeing how to call it, do all that fun stuff. Okay, so let's look at 9.4 then. So we've seen then how to get data to a module. If we want a module or a function to import variables, we list the variables within the parentheses of its declaration, the function header. The function header is what I would call that, where we declare a function or a subprogram. Now, this one's a little bit different. In this example, they're saying, you know, some programming languages, when you declare these parameters here in your subprogram header, they like more than just the variable name. Some programming languages want to know what data type you're passing in too. So in this example, they're saying we're going to actually specify that this variable words is a string. So we've actually put the data type in there. It could be confusing because if you didn't know that string was a data type, you might look at this and say, oh, it wants 2 variables to be input, one named string and one named words. Well, we know that's not the case because there's no comma. There would have to be a comma in between those 2 for that to be 2 different variables. So even if this word here, this data type, was some data type that we had never seen before and we were unfamiliar with it, that would be okay because we know it must be a data type because there's no comma. So that kind of thing will tell us, oh, it must be a data type. So let's see if we can do this in Python. The only thing I wanted to do here was say, can we emulate the same type of thing in Python where we say what the data type is when we define a function? And we sort of can. So let's define our function, surround and display, because this has to do with your plaque for your quest too. So some of you had been working on that before. Now, when I declare this function, surround and display, they're saying it should have a string passed to it. And we want to name this string words. Hang on, let me check this. Okay, so we've got our method, our function here, surround and display, and it wants an input variable named words. In Python, we can use our str function that we've been using to print things out as a string to say that words is a string. So it looks a little bit different than this subprogram definition in our pseudocode, but not too much, right? So let's call that, I'm gonna put a comment over here to the side, function header. It defines a function. So it says the name of the function and the data type and the variable name of the parameters for this function. Now, after I define this function, all it's going to do is print out, what do they have? 1, 2, 3, 4, 5 stars, then a space, plus our words variable, plus a space with 5 stars. So that's what our surround and display function is going to do. So now let's call it So what they did is they decided that they were going to have the user type in the message to be surrounded. So we'll say we're going to have a variable named message, and let's make it a string, and we'll make it an empty string. So I'll go ahead and use that str function to say this is a string. We don't need it. We could do it either way. I'm going to put that out to the side. Same as message equal to double quotes, exactly the same. Now let's set up our message to be equal to whatever our user inputs. Enter a short message. And then whatever they input, let's use it to do our surround and display. So when this program starts, the Python interpreter is going to read both of these and say, oh, we have two functions, surround and display and main. And then it's going to start running the main function. The main function is going to say, I have a variable named message that I would like to set up as a string that's empty. Then I'm going to use the input function to prompt the user and save that data in our message variable. And then I'm going to call our new function with the message data. So let's run it. Oops, it's mad at me. Maybe I can't do that. I was trying to be Python tricky. No, it won't let me. I was going to try to specify our data type in Python, but it's just getting mad, so we won't fight with it. So here's my message. Hello. And then my output is my message surrounded by the stars. So this is why I wanted to go through this stuff before we start on our quest assignment or get a lot further on it, because you might have one person do the plaque function so that you can all share all that code together. Is everybody's working okay? So that one is not much different than the ones we did before, but notice we're taking user input and then we're using that user input as an argument to pass to our function. Alrighty. Whenever we're calling functions, we want everything to be completely separate. We don't like to share global variables because now we're making our functions be dependent on each other. So this next thing kind of shows us how when we pass data, we don't have to worry about a function changing it. So in this example, oh yeah, are we gonna create a Python? We are. Let's go ahead and create this example and then we can run it. So here we're going to set up a function called change value, and it's going to accept one parameter of a number. And all it's going to do in its code is change the number. And our whole purpose for seeing this, for running this, is to see that that variable change only happens within that subroutine. It doesn't affect our main at all. So it's completely separate. We don't have to worry about that data getting back or affecting the place that called. So let's put some code in here. We're going to call this passing by value. And I know they called it example 9.5. So either of those would be good. Demo how a variable is not changed by a function. So let's see, our function here is going to be called change value. And we want a number. And inside that function, all we're going to do is set that number equal to 2. Not a very worthwhile function. So let's set up our main. And in our main, we're going to have another variable, number 1. And we'll set it equal to a value of 1. We'll call our change value function using that variable, number 1. And then we'll print it. And then we'll run our main. So I'm going to run this. You can see all I got out was that number 1. So even though I changed the number to a 2 inside this function, it didn't matter because that only affected the local variable number. It didn't affect the local variable number 1 because that's in our main. Now there is a way we can do that though, and it's called passing by reference. I'm going to look at this next one. And we can't do this in Python. So I have an activity for us, but we might not be able to do it. We sort of could, but it's kind of weird. Some of these are so squirrely, it's not worth doing it. In this example, we're calling a function named switchIt. SwitchIt wants 2 parameters, number 1 and number 2. But notice number 2 is marked with this special keyword as ref. Okay? Now, when we call the switchIt function, we pass in my number and your number. What happens is my number gets used as number 1 within our function. It uses it, it does whatever it wants to, that's fine. Then your number gets passed into our function as number 2, but it's specified as ref. So when number 2 gets updated in our function, that will, in effect, update your number in the main because it was passed by reference. So if I had a, trying to think of a good way to do any sort of board stuff, let's try it. I've got my weird background here. That's not what I want you guys to see. Why are you seeing weird background? By my Zoom session. Okay. Now we can see it. All right, you can sort of see the board. I know this was not the greatest. But what I want you to think about is if we're passing by value. So I have a number here. And it is 1. In my function, I call it NUM, and I say num equals 4. over here in memory, when we're running this program and all of our awesome RAM, open up Redline. When I pass by value here in memory somewhere, I have number 1 set is a 1. And when I create this new variable num, this value gets copied into it. That's passed by value, right? So now number equals 1 and num equals 1. They're separate. If num changes, that's fine. It doesn't have any effect on number. That's passing by value. I copied the value of this variable into the value of this variable. But now if I add that word, those keywords, by ref, then things change. Now, when I've got a number 1 up here for this value, it's sitting at memory location 003FC. When I call this function and my variable is passed by ref, I don't get a copy of it. Instead, I get another reference to that same memory location. So now they're both looking at the same place in memory. So if I change this variable, it's changed for both of them. So passing by reference passes the memory location. Make sense? If I pass by value, I'm saying, oh, here, it's 47. You can have that value. If I pass by reference, I'm saying, oh, it's at 43 Zora Lane. If you go there, you will find it and you can update it yourself. Because now you have the memory address to that variable. We can't do this in Python, pass by reference, because it makes things dependent upon each other that shouldn't be dependent upon each other, right? It violates rules. It's like, well, why didn't we just use a global variable in the first place if we were going to use a variable that is the same for every function? So passing by reference is not hard. It just means both of my variables are pointing to the same place in memory. When I'm passing by value, both of my variables are completely separate in memory, and I'm working with 2 different memory locations. So I can keep it all separate. Let's put something in this one. For student activity 6, let's put a comment. No way to pass by reference using Python unless we use Python lists. And we haven't done those yet. We'll get to them. So I have to go through all of this confusing explanation for something that's like, we can't do this in Python. And it would be less confusing if we could, right? Because then I could show you how it works. And we would be able to tell in that Python tutor thing how it was using the same memory location. So apologize, sometimes we just can't do that way. It's kind of like teaching people what it's like to feel the moon. You can't really do that. Let's go there. Okay, so 9.7 is the big old pseudocode for the whole sale price program pseudocode. It's pretty big. We'll come back to that. Because we need to talk about returning values before you guys work on your quest today. So far, again, we've talked about passing values to our functions, but we haven't talked about how we get a value back. So some of the built-in functions that we used last chapter were like floor and ceiling, integer. You've been using them, right? So we know if we pass a value to floor, like 3.2, the value it returns to us is 3, because it chops off the decimal place. So floor is a built-in function that does that. It takes the value that we pass it in the parentheses, and then it returns a value to us, which is that number truncated. So we've used those kind of functions already. And now we're seeing that we could write our own functions. Those would be user-defined functions, functions that we write as users. So let's look at this cubic function. In this cubic function, they're saying that, I think we're just calculating the area of a cube, because we're saying take the side to the power of 3, something that, getting an area. So it's not a really complex formula or anything. But what is different about this function is that it's doing a calculation and it needs to return a value to whoever called it. So here we see in our main, we're going to call our cube function, and we've actually got the call to a cube function after an equal sign, because the variable name that's before the equal sign is going to receive the value returned by the cube function. So we're going to get a cube for 10, and inside the function, notice how it says set my own name equal to this value, and that's how it returns the value. By setting its function name, cube, equal to a value, that's the return value. We got to do it a little bit different in Python. Let's do it. There's a little bit here for you. Again, I'm going to get rid of this float. So here's our cube function. We've got a cube function that accepts the size of a side, and it takes the side to the power of 3, and it returns it. Now, if I looked at this code up here, that is pseudocode, it says that I should set cube equal to that formula. I'm going to run that. How did we do that power of? Asterisk, that's what it was. I'm looking at it thinking, but I don't think that was right. That's better. So at least it runs. It doesn't do anything, right? But it doesn't give me any syntax errors. That's what I want. So let's add in our main. And they said we want to set up a variable little box, and it's going to be, I'll just set it equal to 0, and then we're going to update the value of little box by calling our cube function with a value of 10. And then we're going to print out the answer. And I need to run my main. Now, I'm doing it the way they say to do it in the pseudocode, and I'm getting this answer back that says none. And Python is saying, I don't know what you're doing here, trying to set this variable named cube equal to something, but it's not getting anything back to the main. I'm going to put in this keyword return, still none. Now I could return that variable, and now I finally get an answer. So I'm going to put a comment here. Python does not allow setting the function name to the return value. Instead, the return keyword must be used. So this will mean more to you as you're reading through the material. In our textbook, they say in pseudocode, if I set a variable named the name of my function, that returns that value. And that's not true. It's not true for Python. For Python, we have to actually say, return this value for it to do it. So since we know how to do it, let's create an area function. I want a function named area that computes the area of a rectangle, and then I want to call that function. So I'm going to give you about, I'm going to set some time on the timer. Don't worry about how much. See what you can come up with there. insurance safety. So everybody got it all. Let's see what I did. Down. I need some comments, huh? Trying to get it done fast with just a few lines of code. Is that how you did it? So I did a def statement to create the function header for a function named area that takes 2 numeric parameters. And then instead of having a variable to hold the answer and returning it, I just used the return statement right with the calculation. And then in my main, I create a variable named box that's going to hold the results of the area calculation using 5 and 4 is the input. And then I print out that area that was returned to me in my box variable. So doing functions is usually pretty clear to people. The hard part is the passing data and returning data back and forth, back and forth. And especially, again, when we're doing such small programs, and it's like, why couldn't I just do that code right there? We want it to be separate. So the quest will give you a really good opportunity to try some functions. And if you don't want to use functions, you don't have to in your quest. You could go either way. So it's a good way for you to explore. Now, before we go to this recursive one, this will be the last thing we're going to look at, and then we'll put this thing up. A recursive function is a function that calls itself. So they always use math problems as examples of recursion, and it can be kind of like, math is not necessarily the most understandable thing in the world, and then we use a math thing to explain something. So what's another way to think of recursion? Let's think of an example. Oops, look, you guys were so fast. Way before our time was up. And I gave you like 6 minutes and you had it all done. So let's think about recursion. One place that's recursive is File Explorer. So let me bring it up. So if I bring up File Explorer, and when I display it, it runs this process to show me everything that I have available. And then if I open the C drive, File Explorer runs File Explorer again to display all the contents of the C drive. And then if I'm on the C drive and I'm like, oh, what's in my program files folder? And I open that, it runs the Explorer process again to list everything that's inside my program files folder. So notice how that's recursive. File Explorer, calling File Explorer, calling File Explorer. It keeps calling itself just to go drill down further and further into those files and folders. That's a recursive process. So when we write a recursive process, we're saying this function is going to call itself. In this example, they're doing a recursive function to add up all of the numbers like less than 4. So if we want to figure out how many different numbers we could have positions for in 4, 3, 2, and 1, we could run this function to see. And we would start out with a 4, and it would say, is n being 4, is 4 equals 1? No. So go ahead and run this sum again using 3 now as the input. The sum function will start up and say, is 3 equal to 1? No. Okay, well then run the sum function again using 2 is the input. We're running it. Is 2 equal to 1? No. So I'm going to say, okay, well then run the sum function again with 1. Now, finally, is 1 equal to 1? Yes. Okay, then add, set the sum equal to 1. And then end the function. So now we finally ended the function, and that's the first time we've ended it because all of the other instances are still running. So now we return and the function that was running for n equal 2 kicks off. And it's like, is n equal 1? No, we'll then subtract 1. So anyways, we can keep having many, many instances of this sum function in memory until they finally all get done. Let's turn this on. So the first time I run sum n equals 5, and that is not equal to 1. So I call sum again with n equal 4. That's not equal to 1. So I call sum again with n equal to 3. N equal to 2. Finally, it calls itself when n equals 1, and it starts adding up the sum. Okay, I'm going to add 1 and get rid of this one. Now I can do something with this instance, like add 2 to it, and then I can get rid of this instance. And then I can add 3 to it and get rid of this instance. So when I'm doing a recursive function, I could have that function loaded into memory many, many, many times as it has called itself. It is a very poor performance, very poor way to do things unless there is no other alternative. So whenever we're looking at a recursive function, we're going to be setting it up to call itself over and over and over. Next time, we'll set up that recursive function in Python, and we'll run it in the code view visualizer thing so that we can see it, but it's not going to have any impact right now on what you guys need to do for your quest. So let's save that for next time to code and analyze, give you something more to think about. So we have a little bit more to finish. But I think that gives you good, confusing information for your quest. Here you were feeling all confident, you were ready to start this quest, and I was like, no, let me rip that away from you and give you some subprogram ideas to think about so that you can go back and think about your quest with some new ideas. Should I put subprograms in? Should we not? Should we just make it all straight through? That's totally up to you and your group. Now, we will have a few minutes of things that we'll need to do next time to finish up some of these things about modules. So bring any questions you have with you next time. But after we finish up those few things, it'll be almost all lab time, I promise. Unlike today, where I said it would be all lab time. Okay, so I'm going to stop my share. I'm going to stop talking and give you at least these 30 minutes of lab time. Any questions before I do that? Got it. Okay. Okay, home people, be thinking about your quest.